Dear followers, we continue today to talk about how we can analyze a system. Usually to analyze a system we use different tools. One of these tools are the diagrams, and one of these, there is many types of diagrams. In this part we will take an overview about these diagrams. We will not talk in details about these diagrams. It is only to show the differences between using the goals of these diagrams. We will remember together what is an information system. We have a system, a real organization. We have a city, a school, a hospital, etc. There is managers of this system. When we manage a system, we use data to understand what happened in the system. With the development of technology, we started to use the computers, so the information system became more complex. There is a lot of technologies that we can use to manage the system using an information system. So an information system can register, can organize, can analyze, transmit the data, etc. So our goal now is to understand how can we create this information system, how we can improve the behavior of this information system. What is the role of the analyzer? The role of the analyzer is to analyze the system. He should understand the components of the system and the internal relation. The analyzer should understand the system. He should understand the component of the system and the relationship between this system, this component, and the goal of the global system and the goal of each subsystem in this system. The result of the analysis is some understandable and standard description, standard diagrams, not only diagrams, but here we will talk about the diagrams. So one of the most important results of the analysis is understandable and standardized description of the system. What is the goal? The goal at the end is to create the suitable information system. We may make the analysis for another purposes, but here in this presentation we concentrate on the creation of the suitable information system. Why we should give a standardized description? What standard mean? This word is very important, and it is one of the basic element in the civilization, in the human civilization. We talked before how all the humanity, using the different tools, became able to cooperate and exchange the knowledge. Standard means that what we give is able to be understood by all the humanity. It respects the norms. So all the humanity define norms, protocols, and what we give respect these protocols, so all people over the globe can understand the diagrams. In such way, the people who analyze can give the results, and the results can be used by the designer, for example, or can be understood by the manager of the enterprise. With such tools, we can, for example, make the analysis in Africa, and we can make the design in Europe, and we can implement the system in China. Of all these people respect the standard norms. This is one of the examples. It is a DFD, data flow diagram. In data flow diagram, we can see the operation. It is very important diagram even to understand the organization in general, not only for making information system. Because this diagram concentrates on the goal of the system and how we achieve this goal, so we can see the operation in the system. As you see, this diagram, this type of diagram, use mainly 4 types of symbols. It is a closed rectangle, oval, arrow, open rectangle. For example, here we will take a very simple example about a school or a university. So we have administration. So we talk about the administration of external administration. It is not the administration of the school itself. It is administration of the university. For example, we are in an engineering school and we have the administration of the university, and we can communicate something with this administration. So all the external layer, the external system, are represented by a closed rectangle. We see here, this is a candidate, there is administration in this example. So one candidate who get the license, in France we say baccalaureate holder, for example, the results of the secondary school, and he candidated to the school, so he give his diploma. So we have an arrow, as you see. The arrow means data that can be transmit or send from one person, one system to another. But here, when it enters the system, it enters not, we can see the operation, why we use this data. If we give the data for nothing, it is not useful. So we can see the system as operations. We can see only here the school, what the school does: inscription, for example, examination, graduation, etc. So in this diagram, we have 4 types of symbols that we can use. It is closed rectangle, oval, arrow, open rectangle, and arrow. So the closed rectangle, it is for the external entities. Circles are for operation in the system. Arrow are for transmission of data. And open rectangle, it is for databases in the system. So we cannot see the member of the system. We cannot see the subsystem of our system. We can see the operations in our system. We can see how the external entities communicate with our system. In our example here, there is, for example, a system for an engineering school. The external entities are administration. It is the administration of the university, not of the school itself. And a candidate give a data. It is his name and it is diploma when he finished the secondary school. And the inscription may take this information to register it in a register, in a database that is registered student. We can take the names of the registered student database to make an examination. Examination is an operation. If the results is good, so we send this information to another database. It is succeeded student. After that, we can get the name of the succeeded student to prepare them for graduation. And when the student becomes engineer, we can send the data to the administration. This is the type of DFD data flow diagram. We see that we cannot see inside, we cannot see the members of the system. Very famous diagram is class diagram. There is a similar diagram that we call EERD, Enhanced Entity Relationship Diagram. We can see here a closed rectangle. We can see lines, some arrow also. We can see numbers. We can see start. Here, in the opposite of DFD, we can see the component and the interaction, the relationship between the component. For example, in the university, we have or in the school, we have a department, we have student, we have year, we have prof. We can see that the entities are not merely physical entities. We can see student and professor, and we can see year, academic year. We can see department. So they are physical and moral entities. So we can see that there is some relationship between a prof and a department using this line. So we can see that is some relationship, and we can see that star. That means teach a professor. We can see the direction of the relationship. A professor teaches in a department. When we put star from the side of the professor, that means one department may be related with many professors. In the opposite also, when we are in the department and we see a star, that means one department, one professor is related to one or more department. Also, when we look at the horizontal line, we can see that one student registers in a department. If we take a look to the one near the department, we can say that one student is related only with one department. The star in the other side, from the side of the student, we can say that one department contains one or more students. So we enter in the details later, but this is a global overview about the class diagram. We have also use case diagrams. In use case diagram, we can see the system from the external point of view. So we can see the users, the external users of the system. If we talk about the university, who are the external users? Perhaps there is an engineer, external student, holder of a diploma of secondary school who want to apply. There is administration. The symbols that we use in this diagram mostly are the oval, a line, a sign that represent the external entity. It is mostly the symbol of a human. So we can see the system engineering school. What is an engineering school? It is with a big rectangle. We can see all the operation. For example, an engineer can request a transcript. The external student can ask for an internship. Baccalaureate holder can apply for the engineering school. Administration can get student names, etc. So we can see the system from the external point of view. So we use this type of diagrams at the beginning of the analysis. Here is another type of diagrams. It is flowchart. It is suitable to represent an algorithm or an activity. The main elements that we can use, it is oval, arrow, rectangle, losange, parallelogram. Usually, because with this diagram we can follow the ideas to execute some algorithm. So there is an oval to represent the start, the beginning, and the end, and there is arrow to represent the follow, how we follow the thinking, the operations to execute the algorithm. So we have, after start there, we have a parallelogram. It means that our algorithm will communicate with the out environment to get something to be in order to be calculated. So read a student marks. We can read the all the marks of one student, and we have the lozenge to represent a condition. If all the marks are okay, so there is two output of this box. All marks okay, yes or no. If all marks okay, we have another question. Also, it is a lozenge. Is the student in the 5th years? It is the last year of the engineering school. Yes, so we give the results, becomes engineer. End. Now, if he finish all the marks, we start, read student marks, all marks okay. Yes, he is in the 5th years. No, he succeeded in all the modules, but he isn't in the 5th year, so he will go to the next year. If he is in the 1st year, he will go to the 2nd, 3rd, etc. So we see the differences between this diagram and the class diagram and the data flow diagram. In the data flow diagram, we saw all the system as operations. In the class diagram, we could see the component and the relationship between the component in the system. Here we saw the algorithm. There is another diagram similar to flowchart that show the activity in the enterprise or in a system, and this diagram can show us the sequence of the activities, and we call it activity diagram. And in such diagrams we can see also who does what, so we can see the responsibility. Another diagram is a simplified. It is a simplified example of ERD Entity Relationship Diagram. In this type of diagram, we use the oval, the line, the rectangle, lozenge, a number also. It is related a little bit to class diagram. We can see the entities. We can see the relationship between the entities. And we have some attributes of the relationship. So we have a professor that teaches a course, and there is an attribute of this course. To the teaching of this course, it is the start date. This is another example of the diagrams. So we saw DFD diagrams that show us the operation of the system and the input and the output, the global input and output of the system with the external environment. We saw the class diagram, that with this diagram we can see the elements, the component of the system and the relationship between this element. We saw the flowchart that enable us to see the sequence of an execution of an algorithm. We saw also use case diagram, how the external entities see the system, and we saw also the ERD diagram, entity relationship diagram. All these diagrams are used together to understand the system from different point of view. For example, this ERD is suitable with class diagram is suitable to create the database. The flowchart is suitable to understand the algorithm and to develop an algorithm.